me just do this here.
I'm recording on my side now.
Recording is on.
That makes me laugh every time. It's
The
I don't know why
voice.
it's funny to me.
The recording is on.
Okay, awesome.
All right. And since you guys aren't here for my bad comedy, I'll just get started. So yeah, this is the like, it, so again, like echoing what Kyle said earlier, like, or sorry, I think Lauren said this, like, this is going to be meant to be a quick lesson, like the quick like core lesson, and then especially with something like data analysis, I think like the question period is especially important, because we can ask questions both about like how does this work or whatever, or we could also ask more questions about the data itself, which I think would be kind of fun and interesting, and it'd be like little like exploration of like, hey, how do we do this? And I then I could kind of show you guys how I would also go about figuring out how to add code to this. Um, but ultimately, and I think this actually comes in later. So I just commented that back in. Oh wait, I just want to move this down here. As this is a very messy file. I'll admit I have like tons of stuff going on here, but the core of what like we're going to be looking at today is everything here. So these like 7 or so lines are going to import a file, a wave file. So a wave file is a like an audio file, like just an audio file, no video, um, and I can't really show it to you another way. Like there's a I guess I could show you. So it's stripped from this song. So I found this like this song, this emotional song. I guess I was in my feels that day, but no, it's about it's a really long like piano sequence, and the reason I did it is I was trying to basically find a deeper understanding of musical notes, and try to teach an AI about that, or like derive patterns through training an AI on um, more emotional songs. And I also like, particularly in the data analysis that we'll go through here, I wanted to understand like, is there a better understanding to notes that can be had, because like um, if we have a G note, for example, a G note, the audio wave sounds different if you play it on a piano, versus if you generate it with a computer, versus if you like play it on a guitar. It's kind of actually lucky that I wouldn't normally have a guitar in the background here, but and so I wanted to understand more about that. And I'm forgetting Kyle. Maybe do you even like know the music theory? I'm kind of like forgetting like there's it's more of a detail, and we'll understand like maybe as we go and as I explain better. Um, but like the scale of the notes is like is not super systematic, I guess. Or it's systematic, but like um, it
Are you talking about how there's 7 note or 12 notes and they repeat 7 times?
that plus like um, the ratio between the scales is different. Like it's not exactly the same for each one, and there's like um, different systems to deal with the differences between those notes. So I think the ratio from like a G note to what would be the previous one? An F note is like, let's say a ratio. I'm making this up here. Ratio of like 1.5 times the frequency, and then like F2 E is like 1.7 times the frequency, and then like the next one would be, and I'm making these values up here, like 1.8, and so it's like, and I think the what I remember the reason was in my research is that ultimately came down to tuning the piano, and the notes ended up being based on the best way to tune a piano, so that when you play a song, it doesn't sound out of tune, even if the ratio is not perfectly mathematical. And so I was wondering, like, hey, like, is there a better definition I could come up with here? Also got really deep into like even actually even Heisenberg's uncertainty principle, but that's a whole other thing to just do with like waves. But so, anyways, I wanted to do data analysis on songs, so I'll just play like a little tiny bit here. And so, like, very complex music. Actually, I don't know if Lauren, can you hear it?
It's very, very quiet.
Okay. Hmm. Yeah, I wonder. Let me try this. Stop share. Also share tab audio. Oh, okay, so I can do that.
Oh yeah, maybe that's the way to go.
Is that better?
It's better-ish. Like you can still hear it a bit, but it's a little quiet, but it's definitely better than before.
All right, so I think that's enough. I could try and find the link on YouTube if you guys want to go find the original video, but you know, I don't want to cry in front of you guys, so you know, it's an emotional song. Probably not a good idea. But I also use FMmpeg to convert this to a WAV file, and so you know, that's what I did, and then that will be the file that I plan to import here. Let's do. Oh, right. Thank you. All right. So the emotional song. So I'm going to import that. And this should be good to go. If I then, so I'm in my REPL. The function's name main prime. Because this is a very hodgepodge code base here. And this might take a second because, yeah, you know what? I think I knew this. Oh, that's actually a little bit quicker than I expected. So, in a second, this is going to bring up a matplotlib plot, and so that matplotlib plot is going to be controlled by this on-screen line. I'm just going to push this stuff down. There we go. Just so we're focused. And yeah, and that, like, this one line does that, which is, like, I think really cool, and that would be the library that we're focusing on today. So yeah, and I'll even show you guys that. Haskell. I guess you could even just search it on Google, but so this is just basically a Haskell library that is an interface to Python. So like, what does that mean? Ultimately, what this is doing, like how this is working under the hood, is just that it's writing a Python script and running it. And for example, we can use this function matplotlib to IO string, and this will print out the full Python code that we are be running. So instead of using on screen, I can instead use code if I wanted to see the code myself, or if I just want to run it and run the action, use on screen. It's been a while since I've used file, but I believe that this would just write the Python code to a file. And so we have this like, oh, there we go. We have this this data type here, matplotlib, which we'll notice, and like I think this is like a common pattern in Haskell libraries, is that if you look at the code, if you look at the type system, or the types they have made for the library, you can almost get a sense of the progression of what you should be looking at. And like what I mean by that is, like, let's say the first thing I see here is on screen matplotlib. Okay, I don't know what that means. It means show a plot, blocks until the figure is closed. Okay, cool. So that looks important. But what is matplotlib? I don't know what that means. And I might look at it and see, okay, it's the wrapper for a matplotlib computation. But also, if I look at a lot of these functions, what I realize is that it's giving back. All these functions are giving back a matplotlib. So from these two types, from seeing, for example, line and on screen, yeah, is my text size good, by the way?
Yeah, I think you're all set.
Cool.
If anyone has trouble seeing that, though, let us know. He can always actually maybe just go in one or two more. Nick is good to go.
Thank you. Really
Hector,
appreciate that. All right, cool. I was like, it's like at the top and the bottom of my screen. I'm like, what if somehow it gets cut off? Bad CSS.
one sec. Did you have something to say? Or maybe you were just agreeing? I'm not sure.
Yeah, that was a mistake, sorry.
Oh, no, you're all good. You're all good. All right.
Right on. Yeah, right on. Okay, so even if we look at like all of these different things, we see that like we could run any of these as like we could write the code to create a bar chart which would output matplotlib, and then based on the type signatures, we can see that we can run that action through on screen to create that plot. And so that's exactly what we did. And we'll get into like how did we get this data. That's obviously important. But just to show you guys, this is a lot of data, so it might take a second. Zooming in. So like I think what's cool too is like I don't know what the point of this statement is or whatever, but I think it's so cool looking at like the different ranges, like time ranges of sound waves. Let me actually just go back here. Oh, that's gonna take a bit. Like seeing this like absolute chaos here, zooming in. And you kind of see like there's like a shape that can happen. Doesn't look like much right now. Kyle's like, oh wait, no, that's the trombone. But and so like as we zoom in, we are gonna start to see more and more defined sound waves. So those even still look a little chaotic. But there starts to become like structures that we could get into, and it may look like it's absolute chaos right now, but that's because like the song itself is absolute chaos. We're looking at like emotional song where there's like 10 notes being played at the same time, and so what that causes is sound interference. Whereas if one wave is like this and then the other wave is the opposite, it's going to knock out the wave so it's flat. And then if they're shifted a little bit, there's going to be a more interesting pattern, which I can't do very well with my hands. Probably better to look at the charts for a interference pattern. And so like even like this like snippet here, which is happening at like I haven't actually like done a good job of saying my like XY axis and labels and all that, but yeah, like we can see that this is like kind of wave interference. I don't think there's any point in zooming in further because we can now see the structure in full. But yeah, so this project was ultimately just trying to figure out more about that, and um, I'll even also for a second play. So I got myself and my fiance to say the words or say the letters E through A or like all the vowels. Um, and so Happy Galen is the next one I'll do. Oh, that's the wrong. I'm gonna close this. Because like you can actually kind of see um, you can start to see like patterns. Did I call it? Oh, I put dashes in there to make my life easier. So this should work. This should be a lot quicker too. And is that my phone? For some reason, I'm very popular this morning. Oh, because it's already looking at recordings. Okay, and so if I run this, there we go. So this is me. This is the sound waves of me saying A, A, A like 5 times over so that I could analyze it. Um, and you can see that like the sound wave let me go back of A has like a shape, I guess. Obviously I wasn't entirely consistent, so I think like towards the end I kind of tapered off, which I can see with my data there. What if I want to also look at E? And I have E Happy Galen because I also have, which implies that there's existence of a sad Galen. I was listening to the emotional song, so went through all the emotions. Um, but come on, oh, that's not gonna. That might actually play a song. I mistyped instead main, which is a um, different little Easter egg I plan to play at the end. Let's see. And you know what? I'll just play all the different yeah. So it's not uh, super different. The differences between like the vowels, at least at this level that we can see. Um, I probably could have also named them instead of having figure one, figure one, figure one. You know what? That's actually I think that's the first one we'll do. So let's. Oh, never mind. It hasn't even come up yet. What is this? This is a bar chart. Oh, am I also making a bar chart? I am making a bar chart, I think. Well, it looks like a bar chart at least. uh, Or no, sorry, that is a. Oh, that's a. Yeah.
Were you screaming into the mic or something here?
maybe. Screaming joy, no doubt. Maybe this is. I mean, based on you know what? Maybe this actually is I, which actually would that make sense? I don't know. I'm gonna run it one more time because I am confused. But I'm also gonna show how to put labels at the end here. Okay, that's interesting. I don't know what that is then. I am very confused. Anyways, so what are we actually doing here? So let's get into like the Haskell code. I think, before we move on, does anyone have any like questions with like the context we're like doing data analysis on, or um, um, I will actually also add one more point. But first check if anyone has any questions.
Kyle, I think you answered most of the questions in the chat, if I'm not mistaken, right?
Bless.
I think so. Yeah. Yeah, I think they're just wondering, like, how would you actually write analysis functions on this? Because this is primarily data visualization at this point.
Yep.
So I think that's what we're going to get into next, right?
Okay. So yeah, the piece that we'll get into next. Yeah, you know what? We'll skip that part for now. I was gonna say the last part I'll add is the reason I was looking at the vowels is to look at a particular pattern, and so that's what actually specifically motivated this project is the pattern that I was looking for is this thing called Kyle, correct me if I'm wrong, attack, sustain, decay, and residual.
Very good.
Perfect. So like, and you would like if you went to a proper spacing here, you would see that there is a pattern that kind of fits. Attack, sort of sustain, or sorry, this is attack, this is sustain, and this is decay, and then this last bit would be residual.
Yep.
So there's definitely a pattern there, and I kind of wanted to like see how could I do analysis on that. And so I wanted to like kind of show that piece because like the analysis that I get into here is gets like pretty quickly complicated. Not this piece of code here, but anyways. So the first thing we're using is this import file function. Oops. Pardon. Okay, so it's from codec.wave. Sorry, allergies are kicking in hard. Sorry.
Bless you.
Sorry, 1 second. Do you mind if we move Dobby out, or is that? Sorry, I remember I have like horrible allergies. Sorry, I forgot my allergy medications. And Kyle has a very cute cat. So yeah, I also have a cat myself, but I just take allergy medications. Okay, so sorry, the first thing I was going to show you guys is the codec.wave. And so this is what we are using here. And this just like I wanted to make through these sessions I kind of wanted to make a point to come back to either, because it's a thank you. Oh my gosh, it's like a very useful function, or sorry, very useful data type to model failure. And so in this case, I'll just zoom in just a little bit. This is effectively saying from the type signature Like I don't even, like if looking at the type signature, this is gonna read a file path and is going to perform an I/O action, which results in either a failure as a string or an audio A. And we'll get into what an audio A is. It's actually very simple, but and the other point I'll make is like if you're new to Haskell, and you're scared by these like type signatures, you're probably scared by the type constraints, or like the type class constraints. So like my suggestion would be just to like if you find that, like read this side first and then look at like, well, what does that mean, because ultimately these only kind of make sense in context of this.
So, yeah, just let's take a quick second with that because I think it's important. So does anyone is everyone here familiar with the concept of polymorphism? Or is anyone have you heard about that word at all?
Feel free to react. Thumbs up, thumbs down. Or a GIF if you're feeling crazy.
Okay,
Nice.
so what they might not teach you, at least I didn't learn this in school, is that there's actually two types of polymorphism. There's what they call ad hoc polymorphism, which basically means that it's polymorphic. How do I explain this? The types themselves don't actually, and we're getting a couple no's, so I will explain what polymorphism is deeper. But basically, there's two types. There's ad hoc, and then there's parametric. So ad hoc is like what you might have seen in object-oriented programming, where you might have the way I like to think about it is it's like you're either going from more possibilities to less possibilities, or from less possibilities to more possibilities. So for example, if I have an animal class, in object oriented, the typical example is you have an animal class, you make it abstract, and then you might have a dog class, a cat class, and a giraffe class, for example. And those all inherit from animal, right? And so that would be just your typical ad hoc polymorphism. Ad hoc meaning I have to define all of the relationships. Basically, I have to create a new class in order for it to be polymorphic. And for those who said no about polymorphism, basically all it means is that how do I explain this in a really quick way? You're inheriting behaviors and properties from another class. So you would have a polymorphic type would be like a square where it's inheriting from shape, right? So it's like a layer of abstraction that, and we can get more deep into that. We will also be talking about it in our lessons, but just in terms of this, what this is with these type class signatures is it's like the opposite of that. So it's called parametric polymorphism. And so what that means is whenever you see these lowercase a, that means that the type can be anything. If you get there's certain functions in here that just go from A to A, and that quite literally means you can put any type in there, and it's just the pattern. What these constraints do is they essentially apply rules to what that type must be. So rather than creating specific polymorphic cases, we can say, okay, we'll take any A as long as A satisfies these constraints. So what this means is, A needs to work with M array, IOU array. These are just probably types for, I'm not actually sure what those types are, but I can look into it. But for example, the second last two, audible and audible in wave. So these are type classes that would actually constrain this file to be an audio file. What this is saying is you can give me any file as long as it's audible. So I can't just give a picture, right? Because a picture would not match the audible constraint. I can't give it a text file because the text file would not match the audible constraint. And if you actually look into what audible is, it's doing a lot of validation to ensure that you're actually working with a sound file, right? And so there might be, I'm imagining inside of Audible, there's probably like a sum type or some kind of classification of all the different types of audio files, what they look like on the inside, etc. And so these constraints are basically saying, okay, we'll give you either a string saying this is not an audio file, or we'll give you an audio file with all of its contents, where that A is constrained by the fact that it is audible, and it's audible in a wave, because this is for the wave. But imagining that there's probably codec.wave, codec. MP3 probably, right? Like, so there'd be .AAC is another audio format. So really what these type classes let us do is parametrically validate. So like based on the parameters, we're able to validate, we're able to unlock more and more flexibility. So it's like, as opposed to starting from like really small and branching out, we're starting from like we have the whole ocean of possibilities. Like you can have A to A, that can be anything, and then we're constraining it. So it gives the functions that we work with a lot more flexibility than like traditional ad hoc polymorphism. So yeah, I think that was just important to note, because and what Gillen's saying there is like, if these look really confusing to you, just for now, while you're learning Haskell, focus on everything that's on the right side of the. So there's two arrows. There's the single arrow, and then there's the equals arrow. And so that equals arrow there is saying, yeah. So that would be the actual type of the function. Everything on the left side of that is just what A is constrained by, right? So you see, anytime you see a lowercase letter inside of, or lowercase anything inside of a Haskell type, it means that it's polymorphic, and it can be anything. But then the constraints constrain what it has to be, and you'll see compile time errors. It'll say does not satisfy constraint, and then you can work through those as you go. And I find like just working through those constraints kind of helps you understand what they actually do. So yeah, don't be. They look a little weird. Some of them you can get like really long constraint patterns, but ultimately all it's doing is ensuring that A is the right type.
Yeah. And to add on to that further, like, so I think this is even like a kind of cool example with this polymorphism. So I'm noticing that like the constraint is on like the output, which it's kind of like, it's cool because it's like almost like an interface to say like, I mean, it doesn't really matter that much here, but like we can ask it to output as whatever type we want. So I have chosen that the audio type will take the int64, and that's just what I chose to do. And that actually I have noticed changes the plotting values. And it makes it. I think when it uses int64, it's a lot higher definition, which is really cool. And all I have to do is simply just change that value, or change what code I have here, and when we look at what an audio is, this is just all the information that we would need to, like, this is just modeling that file type. And while like Kyle's explanation is 100% correct, I just would like to also add that like what's specifically validating the that the file is an audio file is the parser. So the parser is going to give us back this type if the file is actually an audio file. So like let's say we give it like some random stupid file. I can even like try this in a second. what file do I have here? Oh, I think it might even work with that. Okay, what if let's do this. Let's get rid of this anyways. Let's just make this the whole thing. Instead of recordings. So we had recordings here before, and I'll just say instead, default.nix. This is my config file, which is definitely not a music file, although it is music to my ears, even though it has no audio. Oh, and that is not valid. Sorry, my typing is not the best today. There we go. Prelude.undefined. Where did that? Oh, you know why that's happening is because. Okay, so that's happening because I have some crappy code here, which sorry, ignore that for now. So this loaded, and printed out an error. So I'm printing out the results of this error or audio file, and what it gave me back was the error saying left was not expected, failed reading at byte position 4, and so it looks like it's printed out something from the NIX file. Yeah, that's fair. Make derivation, yeah. So it got to. Yeah.
Wait, Kyle, are you saying something to Galen, or are you wanting to say that to
Yeah,
Galen?
sorry, I forgot.
Yeah, yeah, no worries.
Yeah, so this, like, it makes sense that it failed, right? It saw the curly brace, it saw the space, it saw the MK, and then it saw the D, and it's like, okay, wait, this is not an audio file. So that's where it failed.
Can you guys give me 1 second? I'm just gonna. Do you have sorry. Where did the? Oh, there we go. So, do you have any tissues somewhere? Okay. Sorry, my allergies are silently kicking my butt. So yeah, that's what happened there. And I just wanted to explain that aspect of Haskell. I know you guys are excited to get going on the actual like data analysis component. And so the if we look at the audio type, we can kind of see how to go about the next step. Thanks so much. Which is, I want to get the actual like raw data itself, and so I have this sample data. So I call sample data, or the first thing I do is from write undefined raw wave stream, and that's just because like I'm doing a data analysis project. This isn't production, so I was like, you know what, like what the heck, I'm just gonna do undefined here. I'll even change this to like cheap error, and this will just like crash my program, which there's not, if the raw wave stream is a NIX file, I don't think we're gonna have much success anyways. So yeah, so and then associations is from the would be from the UArray type, and so ultimately that's even what the constraints, by the way, were saying. Like those constraints looked very complicated, but now that we're in this context, I want to like call back to them. Like I don't know what these constraints are perfectly well either, but it looks like all this is saying is that A is like can be an element of an array, and two different types of arrays. So maybe somehow in the implementation of import file, they are running something which causes that constraint. So that's why that exists there. But then I see with UArray that where did? There we go. So array, or sorry, assoc just destroys the array and turns it into a simple list. And so then it's easier for myself to do recursion on that list, because I guess that's just how I prefer to do it. And then what do I do next here? I have this length from function, and I want to get the values from I guess 10 million there, and so from 0 to 10 million, I am going to slice the list. And so if I have I think I made this function length from, and so yeah, I have this slice function, which is really stupid and simple. I start by, so slice is a function which takes an integer to start, an index to start at as an int, and an index to end at as an int, and then of course the list to slice, and returns an outputted list. So to do that, I just drop. I use the drop function. So drop is from drop is from the data.list module, and also included in like the prelude. So like this would be automatically imported, and this is kind of like the standard library of Haskell. I don't know if any other language calls it a prelude, or if that's how Haskell specific.
It's a functional programming thing.
Right.
Most they call it STD or standard.
Right. So, pardon me. But the other thing I want to show while we're on this is because I think it's applicable here, is let's say, so we're going to be doing a lot of like list manipulation here. So how could I use Haskell or Hugel in a way that no other language I could do the same? Let's say in my head I'm okay, I have this idea of I want to see if slice exists. I built this function kind of just because I knew how to do it automatically, but I want to see if slice exists, and so I could do one thing. I could look for slice, and I see that slice exists. Okay, cool. But there's a million slices here, and maybe also slices is not the name of the function or whatever. It happens to be something else. I can kind of think about what is the type of this, and I can look for this function by type. So maybe even So I guess that didn't work as well as I was hoping to. But let's say we have we want to look for generic list manipulation functions. We could even just search the type signature like this, and we would see everything that matches that type signature. So we see for example, reverse, which just reverses the ordering of the list. We can see the tail, which just basically removes the first element. Init safe removes the last element. Same with init, and so on and so forth. So I just wanted to show you guys that aspect. Or let's even say we don't know about like drop. I guess we could look for. Would this show it? Oh, and then I guess I'm silly because I forgot to put the result type. So that's saying int to a, which doesn't make a ton of sense now that I think about it. Now that we're looking for the type signature properly, we find something like drop, and so I can look at this and then realize that I can use it for my code. Anyways, so that's what I do here. I drop the start of the list, and then I um, subtract from 2, so that I take the that I take the proper amount of elements. So let's say I'm slicing from 10 to 20. That means that I'm taking 10 elements, and so I could find that by doing 20 minus 10. And so I use that for my length from. I don't know what the difference is between the two. I think I just, yeah. So length from is that, and what do I do here? So let me look at this too. So this gets like, this gets like pretty quickly complicated, and I'll be honest, this is like a bit of an oversight on my part for this lesson. But basically, where do I want to go here? I have this collect function, which is the core here. So I trying to think. Okay, do you have any ideas for like a simpler data analysis we could do here than like what I was planning to do, which is the to max min curves. I just this is. Mm-hmm. How about this? Like, okay, a simpler. Right, that's true. Yeah, let's do our own data analysis here. So like,
Also, Galen, just a heads up that we are reaching to 11, just to be mindful of time.
cool. Okay. Time flies, anyways. Okay, so let's. I think so. You know what? I kind of forget how this data looks exactly. So what I'm going to do is I'm just going to print out the length from 0 to 100 of wave stream. Does that compile? It does compile. Right. Okay, so because that is right. This is the start of the file. There's no sound. So let's do from 10,000 to 11,000. Okay, cool. So that's more what I was expecting there. So if we look at this data, we can see that some are negative and some are positive. So I think what would be a very simple way to start with this is just to try and figure out like how many are negative, how many are positive. Unless does anyone like maybe this is a good time, like does anyone have any questions about the data that would be that we should look at? Because like I know this data well, and so like I have a bias in that I don't know what are good like beginner questions to ask here. So I think that's a good question to ask is like how often is it positive, how often is it negative? But does anyone else have any questions? Okay. Nothing in the chat, right? Okay. Um, so yeah, I'm just gonna ask, how often is this negative? How often is this positive? And so the first thing I need,
Galen,
yeah.
Nick mentioned that you could look at maximum minimum values.
Okay, okay. Oh, that's perfect. So yeah, great idea. Um, so we have, I think the max function,
Also duplicate values.
duplicate values. Okay. Ooh, that's a good one. So maximum is I won't like yeah, you know what? I'll just use this function instead of like implementing it myself. And so this is actually really easy with Haskell because we can just say, I'm just going to print everything. That'll be a little bit more straightforward. So maximum of a this TA. So what this type signature here is, um, this works. Long story short, for a list, because a list, so like the actual like characters of like this, um, is the T in this type signature here. So this type signature becomes maximum of this. So this finds the maximum of a list of A and returns that A, which I think makes sense. And so like also too like this is like a neat example of like polymorphism here is we don't need to have a maximum for int 8 for integer, for you know anything else that has a concept of ord. Um, so like ord is just like an ordering class, and for example, bool has an ord, right? Yeah, and so like you can, where is it here? Yeah, I am correct on that. So characters also have an ord, and so if we wanted to find like the maximum character, which would be like the actual ASCII value, from like I think it's 1 to 140 ish, we can do that, and the point being here that we don't need to rewrite this function, um, for each individual type, right? So this class is kind of overloaded and polymorphic to all of these different instances that we can see here as I scroll, um, which is a ton. So, anyways, so the maximum here, um, the maximum in this range. Oh, and I don't want to print that anymore. And so I can see also too. I'm realizing I meant to do another step here, but I did not. Um, this did the maximum of a tuple. Like so, the A here was a this was the type signature of it. So like maximum of a list of tuples of AA, which I guess would be int 64 and int 64. And instead, I actually want to do just this. So I am going to do another mutation on this type. So I'm going to say I'm going to just fmap I'm going to map a function over this list and just take the first value of the tuple. So how can I do that? So let's say like, okay, so like let's break down this problem. I have a list of tuples, and I want to figure out how to get out my maximum here. So like, what is kind of like the what's the in between here? How do I do this? And the first thing I want to do is, well, break down the problem. So if I have a list of a tuple, keeping it simple, I have a tuple and a list. So that means I can look at functions to work with the list. That means I can work with functions to work with the tuple. And I'm pretty sure we're all familiar with the concept of map from other languages. Like JavaScript has map. There's like, for each. Is very similar.
Also called select, I find.
Right.
Yeah.
And yeah, like, so what I'm gonna do is I like, and maybe this is from like just the first thing I should do is I should look at the tuple, because that's a little bit easier to think about. And so I'm going to go back to Haskell, and I'm going to look for something that can take this tuple and just give me back A here. Oh, cool. Okay, so this is actually genuine. Like, I'm not just saying cool for like the presentation or whatever. It's interesting because it noticed that like um I gave it a more general polymorphic, like, so Haskell is doing polymorphism here, and why that is because this is actually more specific. Sorry, this is more specific than what my input is here. And so why is that? And it's only because of the B here. So one rule of polymorphism in the type signatures of Haskell is that like the A is the same type everywhere. So like whatever A is, like if we were to like kind of do like mathematical substitution here and say like A is int, and then like look at like, okay, how does that, like, what does that look like in this? That means that it's going to be int. But however, like, let's say the original type signature was B here, or I guess that was the same thing. Then, and I say that A is int, then that has no bearing on B because it's a different polymorphic variable. But that doesn't mean that I can't, of course, also say that B is also int, and then it's the same as it being A to A. And again, feel free to ask questions at any time. Feel free to say, Galen, what you just said made no sense. I'm not going to be offended. I very much welcome it because, like, even the language of explaining Haskell I found is, like, not well figured out, or at least not for me. And so I'm always trying to figure out how to explain something like this better. So, yeah. Anyways, so what our actual type signature that we put in here was this, and it smartly gave us this back. And even I'm really curious. I don't know how to test this, but like if we were to put in like this type signature into Haskell, I bet you that it would not give us back something that is like a tuple of AA to A. And by the way, when I say to, I try to have more specific language, but I'm kind of meaning like this, like, return type. So we have an A, B, and return an A. So anyways, so I can write this by saying, well, if I had just one tuple, I could do that, but I don't have one tuple. I have a list of tuples. So what can I use for that? I could look for something in, data.list, and I could probably find it even. You know what? I'll start with that because it's a really easy change. We have our map function. Just loading there. Okay, and it shows you how it works. And so we could use map here and say map first, and this will then go from being a list of tuples of ints to a list of ints, 64 specifically. And so by nature, I would have actually chosen to use fmap, which is just a generic function. So fmap, like how we so map specifically works with this here, or sorry, map is a function that takes a function itself and takes an input value and returns an output value. And so that is the type of map. But what I use it more often and more typically, if you do see me use it, is fmap, which basically says I don't care about what this like type is around it. So like let's say for example I was using like an array. I could still use fmap to run this. And so you can effectively think of it as a more generic or generalized version of map. And again, that's just another instance of polymorphism because the only constraint on fmap is that it's this polymorphic variable f with some constraints, which I will ignore for now, on f. And that's that. So that should now type check and compile. If I want to look at the maximum,
You're gonna want to do last instead of first because the sound value is in the second element.
Right. So second is just the opposite of first. Just getting the other value in the tuple. Just to be very clear with it, this value here, the b. Okay, so the maximum value is this massive number here. So I've trying to remember. This is the amplitude. This should be if I remember the structure of wave files. The wave files. What I chose them is that they are like kind of the most simple encoding of sound, the most stripped back. So all this is is just the amplitude of the wave. So how high or low this gets. And so actually, I'm kind of curious now.
Do you want to maybe divide that number?
Sure. By which?
Just like make it like you could divide it by like a million or something.
That's fair. Okay, let's do. So this is just saying divide by 100 million. And I expected this error. Sorry, Kyle. Can you turn off the sound?
Oh, sorry.
All good. So this is just dividing by a million, but the problem here is that this is saying no instance for fractional int64. And so this, like, we'll get into this deeper another time, but there's quite a vast type system for numbers in Haskell. So, and the reason for that is just that there's certain computations which are only valid if you have a certain type of number. And so, like, if the most generic type class that we have is this this num type class. So this is like this num a, which like works for, like, let's say int, for example, allows us to do like addition. So like let's say I was doing instead addition here, and I'm just gonna show that. Yes. So that's gonna type check. But now if I want to do division by 100 million here, it's going to complain because I have an integer. And so ultimately what I want to do is I want to use the type system to go from my int64 to a num a. I should use a different arrow here. This arrow I'll just use to denote like that, like we're doing some sort of mutation, or sorry, we're doing some sort of computation into the next piece. And then with this num a will fit something that we can do division on. And so we'll end up with we will end up with a float or a double. I think it will default to a double here. So how we do this is we have a function called from integral, which just takes anything that is of the integral type class and can be converted to a num b and does that. So we have the integral. We have the integral constraint on the input and a num constraint on the output, which I call it a constraint.
Recording has stopped.
So yeah, this is like this would be just now value now works as any type of number you want to use it as. Anyways, so let's do that.
Also, Galen, your recording's still going, right?
Yes.
Okay, because my Jitsi stops recording at like random, like it just stopped recording right now. So just confirming that you've still got it.
Yeah.
Also, just doing a time check reminder, maybe, yeah, just focusing on wrapping it up in the next maybe like 5 to 10 minutes. We can have half an hour for questions.
Perfect. Yeah.
Sarah had a question about how you would get the timestamp of the data.
Timestamp of the data.
Of the max.
Oh, okay.
So that would be, in order to do that, basically what you would do is, so there's a sample rate, right? And so we've taken the sample rate of 10,000 to 11,000. Each sample has a number, like has an amount of seconds that it takes, right? And so you would just have to multiply the seconds per sample by the position. So if you can, that shouldn't be too difficult.
Yeah, and there's actually there's one. So there's a bad way we can do this, an inefficient way we can do this, and then there's a awesome way we can do this. The first idea that came to my mind is why don't we find the maximum and then we try and find the index at which that is, and then we can use that index to get the value that we're looking for. However, I'm through thinking through that solution. That's like 3 times that we're looking through the list. However, what you'll find is that Haskell, like I think Haskell is honestly by far the best for like working with lists, which is like working with lists is kind of everything too. Um, if you want to make it that way. Um, but we have this function maximum by, and of course, like for anything, we could implement this function ourselves. If that's of interest, we can do that. Um, I think that'd be kind of fun, honestly. I don't know if I could do it as cleanly, but um, what this is saying is that um, this takes a function which returns an ordering and then a list which we're going to do the computation on, and gives us back that maximum of whatever type that we choose. Um, and again, the foldable type class here is just if you don't understand that, you can just think of it as a list. Foldable is the most common instance of foldable that you're going to use is a list. And so again, if you don't understand that, just it's a list. And so maximum by, I'm going to give it a function here. You know what? And this is starting to get a little chaotic. So I am going to say, you know what? Let me do this. Okay. So we're going to run maximum by, which takes a function, which takes 2 arguments, and we are going to compute the ordering somehow. And so what does ordering mean? Ordering is literally just less than, equal than, or equal to, or greater than as a type. And so, we could even easily write this code ourselves. There's nothing complicated going on here. I won't write it because there's like maybe some type class instances that we want to use, but why is that happening? So yeah, that's all we're going to be doing here, and so what I can do here is, if I think I should be in Prelude. Let me see. Or no, what was? Sorry, I'm forgetting. Oh wait, sorry. There's a function they have here. I believe it's called compare, and it returns an ordering. I was gonna use less than or equal to, which I could use. Let me just go back to Google. And compare. So compare is just our kind of go-to function here. So it takes any two things which have an instance of ord, the ord type class, so they can be ordered, and returns the ordering type. And so I'm just going to say that. So I guess it would just simply be compare AB, and this should work. Yeah. Maximum by is not in scope. Fair enough. Port. I think it's data.list. Couldn't match expected type. Oh, Oh, actually, I guess I kind of do need this. Sorry. So, um, I was assuming in my head, as me, um, I think this is why Haskell is great, is because you can only think about so much at one time. Nothing in my thought process there was stupid. It was just incomplete. It was incomplete because I was forgetting that this is not just like some, like the type of A is not an int. It's actually int int, and more specifically, int 64. So what I want to do instead is I am going to pattern match on this. So I'm going to say A1, A2 is how I'll call this. And then B1, B2. And so actually, let's have a better name for this. This is time 1, time 2, and then this will be A and B. Or time B, I like that better. Time B and, pardon me, time A, time B, and, the A and B themselves. So I want to compare, the reason I'm doing this again, the original motivation here is so that we can find the maximum and then get the time of that maximum. So I guess I don't actually need time. I don't need
don't need
time B
B
or time
or time
A.
A.
Just to, I don't want to like hijack this, but just in order, like in case of time, like I think you already had the solution. You just needed to add one line. Like because originally, like right now, you're F mapping second over it.
Yeah.
But you would just, or I guess, yeah, you just need to return the whole thing as opposed to like map on the second, but then return the whole array. Is that what you're doing right now?
Yeah. So
Yeah, so
I meant to
I meant to
remove
remove
that
that
the f
Okay.
map
F map
second.
second.
All I'm
All
doing
I'm doing
now
now
is
is
looking for the
looking for the
maximum
maximum
and then
and then
getting the
getting the
time at that maximum. So I'm going to say compare based on the A and B itself. But ultimately, what this is going to do instead is instead of returning the key thing is instead of returning a list of A, I'm going to have the full original data of um, the A and B. So I just haven't destroyed the tuple, and I can look for the maximum and then simply just look for second. So before I was F mapping second, but now this is going to return a, a singular tuple, and pardon me, sorry, yeah, this is, I'm just going to remove that. This is going to return a singular tuple, and so all I want to do now is I want to say second. So that should... oh, sorry. I don't know why I have this here. Sorry. Okay, so I had this dollar sign, and what happens with the dollar sign is it says evaluate everything to the right first, and so this was stupid here because like this is supposed to be an argument to maximum by, since maximum by is a higher order function. So if I run this, I see that the time stamp is sorry. I'm also still dividing by 1,000, or sorry, by 100 million. So
Nick gave the solution in the chat, which is great. But I think you both came to the same. I think. Let's see if this doesn't work. Try what Nick did.
oh, okay. I mean, this did work.
Yeah, so I think we're basically doing the same thing.
Yeah.
Nick, your solution's a little bit more elegant, but we're also doing this on the fly, so it's a little takes a little bit, but no, that's exactly what we're doing.
Yeah. Yeah, and I think is on a lens. Is that, or it's not? I'll avoid that one for now. But yeah, because I think
that's a good example though of like there's almost always a faster way to do things in Haskell. Like there's a million ways you can write a function, and they're all going to do the same thing. But Haskell is just filled with abstractions that like you see everything that we did here, and then compare it to what Nick just showed. Like they do the same thing, and Nick's is a lot more elegant, right? So like a lot of the time you're gonna start writing some function, and then you want to ask yourself like, okay, how can I simplify this? How can I simplify this? And that's exactly that's one of the best parts about Haskell, I find, actually.
and to add to that, like I feel like like an experienced Haskellr kind of like looks at any sort of like type signature and says like, how could this be more generic? Like, and I think like foldable is a great example of that. And so like, instead of like rewriting map a million times for each individual thing, which is map like, we can write foldable, which you can see it even gives an example on how to use foldable for like a tree. And so like, yeah, there's a lot of like very clean abstractions in Haskell that like that will definitely make a lot more sense once we can get into higher counted types. Yeah, but I think I'll cut myself off there. If we have any questions,
Yeah, awesome. Just touching on what Esther had asked that Kyle answered. Maybe Kyle, if you could touch on that, because Esther asked if you can demonstrate any of that now. If that's not possible, or like maybe that will take too much time, maybe a follow-up as to how to best work through that example, or you're on mute, Kyle.
Yeah, so I think so specifically, are you asking about the cleaning, the aspect of like cleaning data in Haskell?
Also,
Yes.
Esther, feel free to. Oh yeah, awesome.
Yeah, let's start with the cleaning aspect.
Okay, yeah. So it really just comes down to, so maybe show what would it be? Like, let's say we want to remove. Okay, this is a good example. So let's remove the maximum because, or let's say if the maximum is above a certain value, let's remove it because we want to clean out the like.
do you mean like to filter anything above a certain value?
Yes, filter anything above or below a certain value, because this would be called clipping in or you could even don't remove it, lower it to that threshold.
Lower to that threshold.
Like so say it's above 10 million.
Oh.
Set it to 10 million. Just as a very simple example. I mean, you would want to retain a little bit more of the like you would want to do that mathematically as opposed to just setting it, but just to sort of show how that would work.
Sure.
Because really the whole idea behind cleaning is like it's just you're just validating values, and then either like it really depends on what the context of what you're cleaning is. Like sometimes you'll want to remove values, sometimes you'll want to create like validation functions. Like say you have like say you're looking for cities in a province or something like that. Um, someone might have wrote it with like a lowercase o or a lowercase, or like someone might have put a space where there's not a space.
Mm.
So you would typically it's more of an art than a science, data cleaning. Like data cleaning is really just comes down to first analyzing the entire data set, finding all these different possibilities, and then uh, you can programmatically, like if you've got like 100 values, it's pretty easy to clean that yourself. But if you've got a million values, what you would typically want to do is print out the like all the different possibilities. So we could show that in a separate example. Um, like say you've got a million values and there's like 10 different possibilities, you would want to print out just those values, which could be done with a what is it, a sequence, I think, or a set. Yeah, you would use like an unordered set, and then you would see all like one of each possibility, and then you can write a program to deal with that.
Sorry, I think I missed the first part of that. Can you just explain one more time?
Don't worry. I'm not
Okay,
explaining
my
to
bad.
you. I was just explaining to you.
All
Just
right.
keep typing. Keep typing.
Cool. I mean, if we want to filter out any value above, like this is like the first example that I would think
Yeah.
to do here, which is, I mean, um, yeah, like, and I think like honestly too, like the other thing with data cleaning like is ultimately like what you're doing is you're mapping over like an array or a list, um, 90% of the time. Like even another thing we could do is um, we could like we could map we could sort of smooth out this curve. So we could say fmap um, times 0.5, and this would create a curve. Uh, oh, um, Here, let me do it on this. Let me comment this out for now. Um, so D is going to be the input, and I'm just going to like smooth out the curve by saying fmap times 0.5. I don't really need that there. Oh, right. And I have a tuple again, so I want to do I want to unwrap the tuple times a by 0.5, and then put back the tuple. And there's definitely a more elegant way to do that. For fractional int. So I'm going to say from integral a, and change this so that we are outputting data instead of our d value. Oh, and I need to constrain this. So I'm going to say data is. So this is coming from the matplotlib error, or sorry, from the matplotlib library. What this is saying is that it doesn't know what the type of the first is, the first element of the tuple, and for the matplotlib library, all it's requiring here is that this has a to JSON. That whatever type we're using has a way to convert it to JSON. Here, so I'm just gonna say that this is a double, or you know what? I'm gonna call it a float, just for now. I actually do have another library in here. Well, I'm not sure if that would work though. I think this should still be an int64. So okay, the type of data is a list of float int64. So this should write something out. So I just smoothed out this curve, so it doesn't really look all that different. We could filter out. We could filter out. We could filter out anything that is greater than 1 million, let's do this just to really make it visual. I'm just going to filter out anything greater than 1,000, which will make this look probably really ugly, but we can at least see what is happening here. If A is greater than 1,000, or A is less than negative 1,000, then just put a 0, else A. Or wait, sorry. I'm using filter here, so all I'm trying to return is the boolean. So this is going to this is going to filter out and remove the tuple if the value of A is greater than 1,000. It's the amplitude.
Oh, okay.
Yeah. Huh. Oh, sorry. I want to use not here. So I was saying, take it only if it's greater than 1,000. Yeah, and so that's we don't see any zeros here. Even if we were to like zoom in on this, we should see that it has like some value there. Okay, so let's do that. Yeah. Okay, so let's say, what about over, how many zeros did I add there? I had 4. What about that? How uh, how high is the amplitude of this data? Okay. What if we remove 2 zeros? Cool. We have destroyed the data. Um, and so yeah, like so ultimately like the key pattern that we're doing here that I'm trying to get across is we're doing some list manipulation, and then we're taking that list and then displaying it. That's like 90% of it. Like even like
This is all of data analysis, pretty much. Like,
like even
yeah.
um, let's say we had like Kyle's example of like cleaning data before. This be a list of string.
hmm
Um, uh,
Yeah, and then Canada,
what would be another? Oh yeah, okay.
Canada, and then lowercase Canada, and all uppercase Canada.
Um, yeah. So I guess like this is like super messy. But let's like sorry, this audio.
Oh,
Sorry. So let's say that like we have a list of 1 million of these, but like ultimately if like from our quick analysis we see that like this is like largely what the answers were. The first trick I see here is and this might not work if we are also working with like a town like Cartagena or something that also starts with CA. But how I would go about this if you know if it's like we're talking about simply just North America, we have Canada, USA, and Mexico. Um, we know that the only thing that starts with a CA is Canada, so I would just say we should do.
could you also just say if it's any of those values, just set it to CA? So like, give it test
You could,
input.
yeah.
That'd probably be more of like a what you would do in data cleaning, because it arbitrarily checking CA might be dangerous, especially if you have a database of 1 million values.
And this is true. Yeah, so that's a good example too. Um, so this is just going to be a string to a string. So we're going to take in a string and we're going to output a string. And so, pardon me?
Maybe use the LM function, not LN, ELEM, to check if something exists in the
Oh,
list.
so I was going to use a case statement here just
Okay,
because
sure.
um, this is probably the best way to do it. So like also to let's say there's multiple rounds of cleaning that we're gonna have to do. Um, so um, we also have to handle like what's gonna happen with America, and the most straightforward way to do this function, at least based on what my understanding was of what you're saying, Kyle, and there might be a better implementation here, is just simply to go through and kind of like correct it to. Um,
Yeah, this is the most straightforward. Like you could use a function to do this, but this is doing the same thing.
yeah. Um, and so but even too, like let's say I get to like here and like this is just kind of becoming cumbersome, like in a lot of manual work to do this. What I can do instead is I can um, use where. So and I'm going to say that string is actually um, um, lowercase. So I think this is what it was. Does that type check? Or oh, why is that? Oh, because I don't have anything here. Let me see. Fmap to lower. Import data.car. So I can see my type here to lower. If I import data.car, the type of to lower is a car and a car. So if I do to lower of a, then it gives me back a lowercase a. And by the way, a note here on the like if you're coming from JavaScript, this might be noteworthy for you, is that this is not the same as this. So like in JavaScript, you can use either of these quote marks to write a string. But in Haskell, this specifically means a character, and this specifically means a string. So like if we were to say, for example, to lower, it would say, I don't know how to do this, and so we'd want to use fmap to lower on a, which is also ambiguous. Because I have probably overloaded strings on, so sorry. This is, I have a language extension to make writing code a little bit easier, but because there's multiple different types of strings that you can do in Haskell or use in Haskell. So anyways, I've fmapped to lower, and so some of these become redundant. I don't need this anymore. I can assume that this is going to be Canada. No, that's it, really, right? So, oh, and then otherwise, you know, yeah, other, just, you got to say other. So now this is handling every single case because this will just match on everything that we didn't previously match on. And so how it'll look first for CA, it'll look for Canada, and then it'll just say this is other, and then do whatever we want to with other. Yeah. So we'd say cleaned equals fmap clean on test input. Pardon me? Yeah. And cool. So that's our cleaned output there. We also have America. And I guess like this would get into, we might even have values that make no sense. Maybe we had a very lax input type or lax input system, and someone put America because they thought it was like fun or something. And so like we could also then even do some further cleaning. Let's also do this. Let's say, well, I guess, yeah. I'll maybe leave that, but we would just effectively want another. We could do another clean function, which just uses is prefix of. So we could say, I'll just say clean two is like, like, yeah, or like let's ignore America for now because Canada is better. No bias there. And what we can say, we could turn this into instead a bar. So I don't even know why I copied this, to be honest. Let's do this So I'm just cracking this out into this piece here. So it's going to fmap. It's going to make it lower, and then we're going to run our clean function. So we know that everything coming in here is going to be correct. The only way that something can be incorrect is if we haven't handled it yet. So, okay, string is equal to CA, then we are just going to return CA. And so all this bar is a more generic case statement. And so it allows us to write any sort of arbitrary logic to check if it matches that logic. CA. And if we have the string is an infix of string, or sorry, yeah, right, is prefix of string of, or sorry, if Canada is a prefix of the string, then return CA as well. And so that's like just another way we could do, data cleaning. Yeah. Any questions though, or?
Just going to hop in here. I left a couple messages for you guys because obviously we want to be respectful of the session that we scheduled for.
Yes.
So 2 things. Number 1, Kyle answered it before, but Galen or Kyle, if you want to touch on it, like to talk about it. Abdul Rahman asked, he said, unrelated question to the current topic, but can we get an overview of how Haskell is used in web development, specifically if there are any libraries or packages that are used on the client side and server side? So just before you get to that, there's also another question from Amelia, who said that she found a lot of things today interesting and confusing since it's her first time and she's trying to figure out how to get by. And again, Kyle commented on it. But if you guys want to add anything to that, and at the same time, if you guys want to stick around for a couple minutes to ask another question, but also keep in mind that these Saturday live training sessions, obviously better to get one-on-one time with Kyle and Galen, but you can always message them on the chat because they're always available to help. So use that as your resource because it's there. And if there's anything else that you want to add / also feedback, because for us, feedback is the best way for us to improve on a continuous basis for these weekly sessions, because just as you guys are showing up, we're trying to figure it out as well. So in these last couple of minutes, maybe Kyle and Galen, if there's no other immediate pressing questions, you can touch on those 2 things that I just mentioned more than what Kyle had said. And anybody else, please leave that feedback, even if you want to leave it privately to me. If you're not comfortable sharing that publicly, please do that because we are so grateful for that. So I'll leave you with that while Kyle and Galen, you touch on those questions if there's nothing else.
Yeah, so for web development, we do plan on doing it. How many raise of hands, how many people here would want to see how to do web development in Haskell? Like it might be a little complex at the start, especially if you're new to Haskell, but I think it's worth at least showing how it's done, and showing how it works.
So a couple of people.
So
2 raised
maybe
hands.
next lesson we can use some of that. We'll try to just keep it like to a basic example. But it is really powerful. Like if anyone's ever used like a framework like React or something, you've probably gotten into, like almost everyone I've talked to with React has gotten into like issues with event management and stuff like that, like where you'll have either an event won't fire or you'll have too many events firing. Like it's very hard to manage your dependency arrays with something like React. Haskell actually makes this very easy because it's not at the compiler level. So if you're doing something wrong, it'll actually tell you before you run your code. And that's a library called Reflex. And so yeah, we're happy to get into that as it is a bit, I don't want to say it's an advanced topic to like scare anyone away, but
We,
if you like to really dive into it, it can get a
It's
bit more
the
advanced.
ultimate boss.
we,
It's the ultimate boss, yeah. Yeah.
we can definitely start simple with it. Like I
Yeah.
think,
Yeah.
yeah, there's simple examples we can start with.
Yeah. Yeah. I think the best way too for you guys, like, this kind of goes to Amelia's point of like some of you might not really know, like you might know Haskell to basically everyone in this room has like varying degrees of how much of knowledge on Haskell, right? And so like the purpose behind uh, these meetings specifically is to go over practical examples, to to basically just to see how like we actually go about problem solving in Haskell, as well as to like challenge us, like ask us questions, ask us and we've had a lot of good questions in this meeting, which we're happy to see. Like,
Yes.
okay, well, how would you do this? And then we have to try to figure out how do we do it. Like we're doing a lot of this live. Like a lot of this is just on the spot with people watching. So like it's a lot harder to code with someone breathing over your shoulder, as like some of you might know. Um,
No pressure,
so like
Galen. Just
yeah, Galen
kidding.
did great, but it's very much meant to be that. But if you're looking for like how do I write Haskell? Like what is this double colon syntax? What is this dollar sign syntax? Like how do I actually write a function? What is a guard? What is a monad? What is uh, like all these different things? Like we're putting together training, and we have I think 3 or 4 chapters already written. So, and I'm still continuing to write those. So like I would suggest going through those. We're trying to take you from like zero to hero, like if for Haskell. Um, and so that'll be like your best way to learn the language, try out some exercises, that kind of thing. And then these lessons are very much for like, okay, how do I use this in a practical sense? It also gives you an opportunity to ask questions about like the previous lessons. Like we basically the ultimate goal here. We have a bunch of projects lined up, and as you finish those projects, that we'll be reviewing them, asking you questions about how you wrote them, like making sure that you understand what you're writing and these kinds of things. And then we're using that information to like as a recruitment agency, right? So like it's not just a recruiter that kind of finds a pool of people, reaches out to a bunch of random people on LinkedIn and asks if they need a job. We're actually trying to build up the talent pool and be able to to speak on your behalf, right? Like we can, and like there's that level of trust between us and the businesses, so we can kind of get you right into the door without having to uh,
Jump through a bunch of loops and
like
hole.
go through a bunch of loops. And like anyone who's worked with a recruiter knows that like you just get reached out on LinkedIn and then you have like a 15-minute call with them and you're trying to like explain to them like what you've done, but they don't really understand what you've done. Like that I've never talked to a recruiter who actually understands programming. So it's very difficult that way. So what we're trying to do is actually teach you and be able to advocate for your knowledge as professional engineers. And then Lauren working on the business side. So very much like interact with the content that we have on Ace Talent. The website is still in development. We're still working on through a bunch of kinks and stuff. But like we really need you guys to test that out and to let us know if there's anything we can improve on. So
Mhm.
yeah.
And even too like, um, if like the questions that you guys will ask like will really help us to just figure out how we need to edit the lessons. Like there's already been some great questions in the past that have made us kind of realize like there's an oversight on our part, and like there's like we're kind of I don't know if you guys are familiar with like the idea of like the curse of knowledge, but with us knowing Haskell, um, it's so easy for us to have an oversight on what we're teaching you, and so we want to kind of minimize those as much as possible. So like again, we're not gonna be unhappy in any way that you guys were you found confusion in the lessons. We will be unhappy with ourselves maybe because we're going to try and work those kinks out. But like we will thank you for those anytime. And even I think we didn't do it perfectly well today, but we wanted to get this lesson done as fast as possible so that it could be like as many questions as possible could kind of come at the end, which I think we kind of did, but I think we'll kind of do better next time. So yeah.
Lauren, you have your hand up. Yeah, go ahead.
Yes, thank you. I just wanted to give a shout out to Enoch as well, because he's actually the first person to complete the first project that we've put out. So we are really happy about that. And we're hoping that even maybe at some point that Enoch can be part of the lesson, or we can do something like that, because the other aspect is building you guys up to master this kind of content and do these projects. So just wanted to give a quick shout out to Enoch for doing a great job, and excited to have more shout outs as we go. But just wanted to do that quick highlight because a lot of effort. We want to acknowledge that and make sure that you are being seen for that. So just a quick shout out there.
Isn't it even like the first two lessons, I think, or?
Yeah, you completed the first two projects so far, which is good.
Enoch, you're 10 steps ahead of the game here, my friend. Awesome. All right. Is there anything else? Any other questions? Or even if you have a question that you want to bring to the platform, if you're ready to drop now, because I know we're 5 minutes over time here.
And sorry, and I just the last thing I wanted to say with like the web development, going back to the web development question, is ACE is entirely built with Haskell, including the front end. So we use the Reflex library that we will be showing you guys for the ACE platform. So yeah, just wanted to add that in.
Awesome. Okay, I think we're all set for today. Again, thank you guys for showing up, engaging, asking questions. That's what really makes these sessions awesome and makes us put in the time and effort to make these things really great for you guys. So we're looking to improve week over week, just as you guys are in your job search and your efforts and your learning journey. So thank you so much for showing up today and really engaging with all the content. And what I'll do is I'll also just circulate that feedback survey after the session, because that's actually been really helpful for us to understand what to keep on doing to improve. Thank you for the applause. I love these reactions. They kill me. But yeah, feel free to submit that feedback if you want to do it anonymously, or you can always message us. And I'll also just sorry, it's so funny. Thank you, Sarah. Thank you, Amelia. Thank you, Hector. And like I said, just last quick reminder, you can always reach out to us on the platform, not just in these sessions alone. Like Kyle said, get started on those projects, start reading through the stuff, whether you're looking at it for the very first time today, or you've already done a couple of projects like our superstar Enoch here. Just keep going. We're going to make some great progress to close out the year. And then the beginning of 2025 will be nothing short of incredible. So let's keep powering through and have a great rest of your Saturdays, everyone. All right. See you guys.
Thanks everyone.
Thanks, everyone.
Thank you. Bye.
Thank you, Sarah. Thank you, Nick. Hi, guys.